Hello everyone, Simon here, and let's go back to talking to Google Gemini about neuroscience and psychology. So in this one, I want to ask about sexual orientation. I want to ask about why are people gay? Um, so up until now, we've been talking about disorders, right? Like problems with the brain. Now, being gay used to be considered a mental disorder. We don't consider it a mental disorder these days. But nevertheless, there's something going on with the brain, right? Like everything is going on with the brain. Like whatever it is you do, it's in your brain. So why do some people like guys and some people like girls? Like why do some guys like guys and why do some girls like girls and why do some people like everybody? Let's ask about this. See what Gemini has for us. Uh, Next, I want to ask about the neuroscience of sexual orientation. Um, have scientists pinned down the part of the brain that is for sexual attraction? What does it tell us? What does it tell us about homosexuality versus sexuality or other uh, forms, I guess? Um, sure, let's start with that, see how it goes. The neuroscience of sexual orientation is a field that has moved from theories of choice to theories of biology. While there is no single gay switch in the brain, researchers have identified specific hubs in the basement, the hypothalamus, and the limbic system that differ based on sexual orientation. There's no single gay switch. Interesting. Well, the thing is, look, sex, right? Sex is a basic animal behavior. And so, like sexual reproduction has been going on since we were fish and earlier, right? And so, because it's so ancient, we expect it to be deeply ingrained in the brain, right? Like even worms have sex. Like every animal has sex. Well, except like some single-celled organisms, I guess. But as we said, even worms have sex. And so, like, because it's so primitive, it's going to be deeply ingrained throughout the brain. So we don't expect to find, like, oh, this part is the gay part. No, it's not like that. Like, because it's going to be everywhere, right? In our three-story house, sexual attraction is a basement function. It is in an innate hardwired drive that exists long before the penthouse, the CEO, develops the language to describe it. Right, so this Gemini is just saying exactly what I said before. Like it is deeply ingrained into the brainstem, the basal ganglia, um, but it affects everything else. All right, so one, the hub of attraction, the INAH3. The most famous discovery in this field involves a tiny cluster of neurons in the hypothalamus, called the interstitial nucleus of the anterior hypothalamus 3. That's very, very specific. Inst interstitial nucleus of the anterior hypothalamus 3. So there's at least three of them, possibly more. And it's like it's inside the anterior hypothalamus. So we've pinpointed it there. The findings in the 1990s, neuroscientist Simon LeVay found that the INAH3 was significantly larger in heterosexual men than in heterosexual women. So this is the part that is attracted to women, I guess. The orientation twist. Crucially, he found that in homosexual men, The INAH3 was similar in size to that of women, about half the size of the nucleus in heterosexual men. The meaning, this suggests that the machinery responsible for sexual target seeking is physically shaped differently, depending on who the brain is wired to find attractive. Right. So they have actually pinpointed the part that makes you gay, or the part that makes you attracted to women. Huh. Or at least that's one part. There might be other parts. They found one part. Two, brain symmetry and connectivity. Research has expanded beyond the hypothalamus to look at the overall architecture of the brain's two hemispheres. Hemispheric symmetry. Heterosexual men and homosexual women, lesbians, tend to have slightly asymmetrical brains, with the right hemisphere being slightly larger. This part bigger than this part. So heterosexual men and homosexual women, so people who like women, have slightly bigger right brains. Whatever that means. Hemispheric symmetry. Heterosexual women and homosexual men tend to have symmetrical brain hemispheres. Huh. The connectivity cable, the anterior commissure. What the hell is it? You know what? I should look this up too. I don't suppose this is going to be there. Interstitial nucleus of the anterior. No. Hypothalamus? Hypothalamus. Hypothalamus? What is it called? Anterior hypothalamus. Anyway, it's that thing, right? It's that thing. Oops. Don't. Whoa, 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 whoa. Oh, whoa, 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 whoa. Hypothalamus. So something in there, in the back part, because it's anterior. Right? Oh wait, the bacteria is no anterior. It's the front part. Somewhere, I don't know where it is. And then the other one, the connectivity cable, the anterior commissure, a bundle of wires connecting the two sides of the brain, has been found to be larger in homosexual men than in heterosexual men, mirroring a pattern more common in women. So in women and homosexual men, the two halves of the brain are more strongly connected to each other. Anterior commissure. Nope. Nope. Alright, this brain model doesn't quite have all the parts that we're looking at. Like, it could be like a different name. The pheromone response. Scientists have used brain scans, PET and fMRI, to see how the brain reacts to scent chemicals associated with gender. The hypothalamic reaction. When heterosexual women and homosexual men smell a derivative of testosterone, found in male sweat, their hypothalamus lights up. Heterosexual men do not show this reaction. So the hypothalamus in women and gay men activate when they smell male sweat. The amygdala reaction. When homosexual men and heterosexual women are shown images of attractive men, the amygdala, the emotional alarm/reward center, fires in identical patterns. Right. So this is the neuron activation for homosexual men and heterosexual women. But this is interesting, right? So the heterosexual men and lesbians, with straight men and lesbians, their brains react the same way, and then gay men and straight women, their brains will react in the same way. What causes the wiring? The prenatal theory. If the brain is physically different, how does it get that way? the leading scientific consensus is the prenatal hormonal hypothesis. The hormonal bath. During critical windows of pregnancy, the fetal brain is bathed in different levels of testosterone and other hormones. These hormones don't just affect the body, they organize the brain circuitry. Right. So testosterone versus estrogen, or like androgen versus. So like these hormones, they're in different levels based on what gender you are, or like what sex you are, whether you're a man or a woman. Usually. But because they're hormones, hormones can go wrong, right? You can have like a hormonal malfunction sometimes. And so like you can, and the pregnancy, um different parts of your body develop at different times. And so if your hormonal levels are unstable, certain parts of your body can develop one way, and then other parts can develop other way, depending what develops earlier and what develops later. And so yes, it is actually possible for someone to like have a male body and then a female brain because like the hormones fluctuate and parts of the body develop earlier than parts of the brain. And so then you have different levels of hormones depending on when you're developing. So stuff like that can happen during pregnancy. The epigenetic layer. This explains why identical twins who have the same DNA don't always have the same orientation. Huh. One twin might have slightly different access to blood flow or hormone receptors in the womb, leading to a different wiring of the INAH3. Yeah. So it's not just your genes, but it's your epigenes. Epigenetics, remember, is switches on your DNA. So not the DNA itself, but the switches on the DNA that can switch on and off parts of your DNA. So like different access to blood hormones inside the womb causing different epigenetics, causing different sexual orientations. Wild. The older brother effect. There is a well-documented phenomenon where each older biological brother a man has increases the probability of him being gay. This is thought to be an immune response to the mother that slightly alters the hormonal path for subsequent male fetuses. This is thought to be an immune response in the mother that slightly alters the hormonal path for subsequent male fetuses. Okay then. So one of these things that people don't talk about all the time, but it's real. So evolution is messy, right? The baby tries to draw more nutrients from the mother for its own benefit, and the mother tries to restrict nutrients going to the baby to keep herself alive. So in humans, there's like a tug of war going on between the mother and the fetus, deciding how much nutrients to draw. And so there's actually the body does have a kind of an immune response against the fetus, believe it or not, because the fetus is trying to draw more nutrients, and the mother is trying to control how much nutrients to feed to the baby, so she doesn't die from all the nutrients being drawn away from her. So that's actually a real thing. Um, hmm. All right, summary. Orientation versus behavior. Brain feature typical male pattern brain. INH3 size larger. Typical female pattern brain. Smaller. Hemispheres asymmetric, symmetric. Right, thinner anterior commissure, second anterior commissure. Heterosexual men usually show the male typical pattern. Homosexual men often show the female typical pattern in these specific regions. Homosexual women often show patterns shifted towards the male typical architecture. Interesting. Alright, so I want to ask about, has anyone ever had an injury? Had anyone ever had some sort of injury or disease in the INAH3 that caused them to turn gay or turn straight? Have there? Okay, if the part of the brain, or if the parts of the brain that deal with sexual orientation have been identified, have there been any cases? Have there been any cases of a person getting some sort of brain injury, a brain that changed their sexual orientation? Any recorded cases? We're gonna have to check the references if there are. Because we know that to the brain can change behavior. Has somebody turned gay because they were injured? This is a fascinating edge case in neuroscience. While we know that brain injuries can change behavior, the question of whether they can change orientation, the fundamental target of attraction, is much more complex. Okay? I mean, imagine somebody performs surgery in your brain and you turn gay. Imagine if we can get to that level of precision in neuroscience and in, brain surgeries. You can target specific neurons in your brain and you turn gay? Now, first of all, why would you do that? Because it's funny. Second of all, imagine if you could do that to a person's brain and you just change anything. They can become anything. In the three-story house, an injury to the penthouse prefrontal cortex usually changes how you act on your desires, while an injury to the basement hypothalamus limbic systems can, in very rare cases, change the nature of the desires themselves, right? Uh, disin disinhibit disinhibition versus orientation change. The most common change seen after brain injury, like Phineas Gage, is hypersexuality or disinhibition. The penthouse failure. The CEO's office is destroyed, so this part is injured. So the person loses their social filter. They might start making sexual advances towards everyone, men, women, even objects. I mean, that's fun. Is it a change in orientation? Usually no. The person hasn't changed who they find attractive. They have simply lost the no-go switch that tells them when it is inappropriate to express it. Their basement is still sending them the same signals, but the penthouse isn't filtering them anymore. Oh, the other thing is, because like your thalamus is deep inside your brain, right? So if you're gonna get an injury, you're more likely to get it on the outside. You're less likely to get it right in the middle, deep inside your brain. Like, why did you get injured there, right? So it's very unlikely, well, it's relatively unlikely for you to get an injury all the way in there. And if you do, you're probably gonna die anyway. Whereas if you lose bits of the outside, you might survive. Like you lose bits of your cortex, it's less likely to be, I mean, you're still gonna die sometimes, but it's less likely to be fatal and more likely to happen because it's on the outside. So like injuring specifically that part and then you turning gay, extremely unlikely to happen. But you don't know. Maybe you get a stroke or something. All right, the rare switch cases. There are a handful of recorded medical cases where a person appeared to experience a genuine shift in sexual orientation following a brain event. Notice there are no references, so we might not believe this. These cases almost always involve the temporal lobes or the hypothalamus. The case of the peduncular hallucinosis. In one documented case, a man developed a tumor near his hypothalamus, the INH3 region we discussed. He reported a sudden shift from being exclusively heterosexual to having intense attractions to men. When the tumor was treated, the attraction patterns shifted again. We're not sure if we believe this, so I'm going to Google this, but not live, because I don't know what's going to happen. Let me open a new window. You can't see this new window? Alright, you can't see this new window, but I'm going to just type peduncular hallucinosis versus Charles Bonnet. Um, Peduncular hallucinosis, a case report. I'm not finding it. I'm not finding it on Google, so we're not going to. We're not gonna believe this. Show more. Mm, yeah, no, I think Gemini might be making things up there. Huh. Characterized by the abnormal belief, delusion, or overvalued idea of infidelity. But that's infidelity. Mm, maybe he was already gay, and he was just repressing it. So there are sexual hallucinations. Sexual preference? Um, hypersexuality, appropriate versus inappropriate sexual partners, lesion in the amygdala. Hold on. Patients with Culver-Bucy syndrome, bilateral temporal limbic damage, engage in indiscriminate oral and tactile exploration of their environment, hyperorality and the hypermetamorphosis, and change their sexual preferences. Such individuals exhibit a flattened affect, and report diminished subjective emotional response to stimuli. Aggressive behavior becomes uncommon and apathy and placidity occurs. I mean, there are things that can make you change your sexual preference. Alright, this inhibition, hypersexuality, altered sexual behavior, hyposexuality, altered sexuality, neurological disorders can produce alterations in sex drive. Lesions of the orbitofrontal lobe may remove the moral ethical restraints and lead to indiscriminate sexual behavior. But we're not talking about we're not talking about someone turning gay though. Okay. Alright. So we don't really believe this? I don't really believe this. There's no reference? Can I ask it to check itself? Temporal lobe epilepsy. Some patients with seizures in the limbic system, the emotional basement, report paroxysmal changes in attraction during or after a seizure. This suggests that when the electrical wiring of the basement misfires, it can momentarily scramble the target-seeking software. Right. Why is it so rare? Orientation is incredibly stable hardware. Unlike personality, which is a complex software suite in the penthouse, orientation is built into the foundation of the house during fetal development. Yeah, so it's deeply ingrained. Hardwired redundancy. The circuits for attraction are deeply embedded and connected to multiple survival systems, like the reward system. It takes a very specific, localized injury to rewire the target of attraction without destroying the person's ability to feel attraction at all. Okay. Brain damage usually breaks rather than rewires. Right. So a person might become asexual. Most brain injuries result in a loss of function, libido loss, right, asexual, rather than a change in function. I get it, because it's like there's two circuits, right? There's the attraction to men circuit, and then there's the attraction to women circuit. If you are attracted to men and your attraction to men circuit breaks, it doesn't mean it'll activate or create an attraction to women circuit if you didn't have one before, right? Hmm, fascinating. Gonna ask you to double check. I'm gonna ask you to double check. Check completed. Yeah. So this Google search found content that differs. Yeah, no. This is made up. So everything else is fine. This particular part is made up. Yeah. So the Google Gemini tried to find me what I want, but it couldn't, and so it's made it up. Sometimes AIs do that. You need to be careful, right, with artificial intelligence. I want to ask, what about asexuality? What about and bisexuality? Have these been sufficiently researched for us to know about what is going on inside those brains? What is this? If heterosexuality and homosexuality are different tuning settings, so male or female, for the same radio, bisexuality and asexuality represent different ways the tuner and the volume knob are wired. While research into these orientations is newer than the study of the gay-straight binary, we are beginning to see distinct neurological and physiological patterns for both. Bisexuality, the broad tuning brain. For a long time, bisexuality was wrongly characterized as a midpoint or a transition. Brain imaging has debunked this, showing that bisexual brains have their own unique arousal signature. Okay. The reward system. When bisexual individuals are shown images of both men and women, the basal ganglia and the ventral striatum, the brain's yes centers, fire in response to both genders. I mean, that makes sense. They are bisexual after all. What is the ventral striatum? Ventral. I should just look up striatum. Striatum is that. Ventral is the sides or the middle? That's the striatum. The generalist wiring. In the hypothalamus, the INH3 region we discussed earlier, bisexual individuals often show a hybrid architecture or an intermediate size, suggesting that the target-seeking software is set to a wider frequency rather than a narrow one. Brain symmetry. Research suggests that bisexual women often show brain symmetry patterns more similar to heterosexual men, slight asymmetry, while bisexual men often show patterns closer to heterosexual women, more symmetry. But they are halfway then. Um, curious. Curious. Asexuality. I mean, there hasn't been that much research yet, so we're still trying to figure it out. Asexuality, the volume versus target distinction. Asexuality, a lack of sexual attraction, is perhaps the most misunderstood. It is essential to distinguish between asexuality, a biological orientation, and a hypoactive sexual desire disorder, a medical malfunction. Huh. The targeting software in a person with a low libido, medical, the brain might still want to find the target but lacks the energy. In an asexual person, the targeting software itself simply isn't looking for a sexual partner. Right, so there's two different things. There's the target and there's the volume, right? Or the target and the intensity. If you don't have a target, that's one way to be asexual. If the intensity is zero, that's a different way to be asexual. The arousal pattern. Functional MRI scans show that when asexual individuals are shown sexual imagery, the visual cortex processes the image, they see what's happening, but the limbic system, the emotional basement, and the thalamus do not flag the image as personally relevant. Not interested. Not interested. The default state for many asexual people, the sexual volume knob in the hypothalamus is simply set to zero. The three-story house is fully functional and they can feel deep romantic love, which uses oxytocin. But the sexual engine in the basement just isn't wired to the drive gear. Super interesting. Right, so they're just not. They don't have a response. They don't have an emotional response to the idea of sex. They do have a emotional response to, like, romantic love. Mm. The romantic versus sexual split. One of the most important neurological discoveries made through the study of asexuality is the split attraction model. The sexual circuit, driven by dopamine and testosterone in the hypothalamus and amygdala, versus the romantic attachment circuit, driven by oxytocin and vasopressin in the pituitary and ventromedial prefrontal cortex. So sex and romance are two different things. Completely different things. That's why people sometimes cheat on each other. They want to have sex with one person and they want to have a romantic relationship with a different person because they're two separate circuits. And you don't necessarily expect them to point in the same direction, right? Asexual people often have a perfectly high-functioning attachment circuit. They can fall in love, form pair bonds, and crave intimacy, but the sexual circuit remains inactive. This proves that love and lust are handled by two different utility lines in the house. Yet they're two different circuits. What causes these variations? The same prenatal hormonal hypothesis applies here. Bisexuality may result from a specific middle ground hormonal exposure during brain development, creating a versatile reward system. Versatile. That's one way of putting it. Asexuality. Some theories suggest a lower sensitivity to prenatal androgens like testosterone in the specific brain regions that manage sexual salience, even if the rest of the body develops traditionally. Okay then. Okay then. Hmm. Uh, so should we ask about gender dysphoria? What about dysphoria? If I remember right, or I guess gender identity and gender identity and gender dysphoria. So this is how a person sees themselves, right? Whereas gender orientation, sexual orientation is how they see others. Gender identity is how they see themselves. I guess this is a different thing related to how the brain pers hmm, how a person perceives themselves. But what makes a person feel that their gender is wrong? You were spot on. Gender identity is a different room in our three-story house than the sexual orientation. While orientation is about who you are attracted to, the targeting software in the basement, gender identity is about who you are, the self-map in the penthouse. Oh, identity is in the cerebral cortex? In the ADHD and autism discussions, we talked about a mismatched wiring. Gender dysphoria is essentially a mismatch between the internal map of the brain and the physical blueprint of the body. The self-map, the cortical homunculus. Oh, right, I remember now. It's not going to be there. It's not a part of the brain. So the part that, like your body, the neurons of your body, and how they're mapped in your brain. In your brain's cerebral cortex. I wish that you stopped using these stupid words. What's a penthouse? In your cerebral cortex, there is a specialized strip of tissue called the somatosensory cortex. That I can probably find. Somatosensory cortex is that one. That strip there, right? This area contains a literal map of your body, the homunculus. The mismatch. In cases of gender dysphoria, brain scans suggest that this self-map is wired for a gender that does not match the biological sex of the body. But the only part that's really different, I guess it's like, I mean, maybe breasts and nipples are a bit different, but mostly it's your genitalia, right? Your penis or your vagina. That would be different. So they have, really? Their genitals feel wrong? Because, like, your nerves are mapped to the wrong places? Really? The result, when the brain pings the body to check its status, it expects one set of signals, female primary secondary characteristics, for example, but receives another, male. This creates a constant profound sense of error or wrongness in the brain's most basic processing. Okay, but here's the problem. Gender reassignment surgery does not change the way your nerves are wired. So even after you get it, you wouldn't feel right. Or it shouldn't feel right. Because like gender reassignment surgery, it changes the shape. It doesn't change the nerves. It doesn't change the wiring. So it shouldn't, it wouldn't help, would it? Anyway, let's move on for now. We'll come back to this. White matter highways, the structural bridge. When scientists look at the white matter, the insulation on the cables that connect brain regions, they find that transgender individuals often have highway systems that more closely resemble their gender identity than their biological sex. So again, like the wiring is for the other gender, as opposed to what your body is. For example, a transgender man assigned female at birth often has white matter pathways in the areas of the brain related to spatial awareness and body image that are masculinized. They look like the pathways of a cisgender man. Right. Connectivity. This isn't a glitch, it's a structural difference in how the brain is integrated. The brain is effectively built to run a male or female operating system, regardless of the hardware it was installed in. Huh. But I mean, you know what I'm saying though, right? Like most of the bodies between men and women, most of them is the same. Your hands are the same, your arms and feet and legs are the same, like your torso, and it's only the genitalia, right? And maybe the breasts. But aside from your genitalia, your body is mostly the same between men and women. The basement hubs BSTC and INAH3, just as with sexual orientation. Oh wait, there's no references here. Just as with sexual orientation, there are specific hubs in the hypothalamus, the basement, that seem to follow gender identity rather than the biological sex. Um, the BSTC, bed nucleus of the striata terminalis. Stria terminalis. Stria terminalis. Nope, there's no stria terminalis. This is a tiny cluster of neurons, I mean it's tiny, involved in emotional and sexual behavior. The findings. In cisgender men, the BSTC is significantly larger and has more neurons than in cisgender women. In transgender women assigned male at birth, the BSTC is typically the size and density of a cisgender woman's. Right. The stability. This structure is established before birth and does not change based on hormone levels in adulthood, suggesting the gender blueprint in the basement is set very early. Right. So this part of the brain is fully established before you are born. So like while you're still a fetus, this part is already stabilized. So you are born with the identity that you have, and it doesn't change in adulthood. What is gender dysphoria? The error message. If your brain expects a female body but is living in a male body, the limbic system, the emotional center, and the insula, the part of your brain that senses self, are in a constant state of alarm. I mean, there are other ways to have dysphoria. Like you can feel like your body is wrong somehow. Dysphoria as pain. This is just a thought. It's a visceral experience. The brain perceives the mismatch as a threat to its integrity. The cure. This is why talk therapy cannot fix gender dysphoria. You cannot talk the brain out of its physical map. This is why gender-affirming care, hormones or surgery, is often effective. It attempts to bring the hardware, the body, closer to the software, the brain map, which finally allows the error message in the brain to stop firing. Does it though? Does it bring the hardware closer to the software? Because I don't... Like performing surgery to reshape your genitalia, does that actually do any rewiring of your nerves? Okay, first of all, let's check this. Just make sure, or just double check this. Apparently it's correct. Apparently it's correct. Or I want to ask about gender reassignment surgery. I want to ask about the efficacy of hormone therapy or surgery for gender dysphoria. You said that the that a person with gender dysphoria has the wrong somatosensory cortex for their body. But as far as I know, neither the hormone therapy nor the surgery will change the nerves of the body or the brain enough to make the two match correctly. Am I wrong? I can't imagine how the surgery can like move the nerves around with enough precision. I don't think the surgery can reroute the nerves with enough precision to do that. You've touched on a very sophisticated point about biological precision. You are correct that a surgeon cannot rewire the millions of sensory nerves in the body to match a different blueprint with microscopic accuracy. Neither can hormones reprogram the physical location of neurons in the brain's map. Yeah, no, you can't. You can't do that. However, in the three-story house, the goal of transition isn't to create a perfect pixel-by-pixel match. It is to stop the error signal and utilize the brain's incredible neuroplasticity. Neuroplasticity. Here's how the hardware and software actually resolve that mismatch. Man. Okay, I mean, I'm not sure I like where this is going, but let's keep going. 1. Hormones as chemical software updates. While hormones don't move the rooms in the house, they change the lighting and the temperature. Okay. The receptors. Every neuron in the brain has receptors for androgen and testosterone. When a transgender person takes hormones, they're changing the chemical bath the brain sits in. Okay, I see how that helps. The emotional shift. Many patients report that the fog lifts almost immediately upon starting the hormones, long before physical changes occur. That suggests that the limbic system, the basement, simply functions better when it is running on the fuel it was biologically expecting. That does make sense. Okay. All right. Yes. Yes. Because look, your brain, if you have a female brain, you're expecting more estrogens, right? If you're a male brain, the brain expects more testosterone. But if you have the wrong body, your body is producing the wrong hormones, and so your brain is not running on the expected hormones. And that feels bad, all right? So once you change that, you start feeling better immediately. Structural changes, long-term hormone therapy does actually change the brain. Scan shows that after months of treatment, the white matter, the cables, and the cortical thickness often shift to more closely resemble the target gender. The brain is literally re-insulating its wires to match the new chemical environment. Okay. Right, because your brain changes depending on the environment. You change your hormones Your brain starts to grow in a different direction. Okay. Okay, I see it. Okay, I see how that works. Yeah. Okay. The somatosensory map and phantom versus real. You mentioned the somatosensory cortex to body map. This is where it gets fascinating. Phantom sensations. Many transgender men assigned female at birth report experiencing phantom male genitalia long before any surgery. Oh wow! Phantom penises. No, yeah, because look, your brain expects a penis because the part of your brain where the penis connects to, that part is active. It's just that you don't have a penis to connect to it. Your brain expects a penis, but you don't have a penis, and so you and so you feel a phantom penis. Like people have phantom limbs. So if you like lose a limb, if your limb gets amputated, your brain still expects your limb to be there, but you don't have a limb there, and so you have like you feel phantom limbs sometimes. Well, apparently, I don't know, but according to them, and they feel phantom pain, like they feel a pain in their arm that isn't there anymore, because the brain has still has those neurons that expect you to have a limb where you don't. So I guess the same thing applies to the phantom penis, is that your brain expects you to have a penis, and but you don't. So you have these phantom sensations because the circuitry is there. Right? The brain's map already has those rooms built. The error signal comes from the fact that the rooms are empty. Yeah. Phantom penis. Now I wish I knew a transgender man. Like if I know a trans man, I want to ask them about their phantom penis. Like what's that like? What is it like to have a phantom penis? I guess it's uncomfortable. That's why they want to change it. Closing the loop. When surgery creates a physical structure, it provides a landing pad for the brain's existing map. Even if the nerve connections aren't a 100% microscopic match, the brain uses neuroplasticity to colonize the new tissue. Of course it does. Of course it does. You give the person a new thing, and the brain will wire those neurons into the place that it's supposed to go. Like, if sometimes people like get replacement body parts, like there are hand transplants or like things. Like you transplant like ear transplants or whatever it is. Like you transplant a part of a different thing onto your body. Over time, your brain will learn to wire that transplanted part into the existing brain. So it's like a transplanted penis. And the brain will learn to wire them into the right place. The results, studies show that after surgery, the brain's alarm system, the amygdala and insula, finally quiet down. The brain accepts close enough as a massive improvement over not at all. Yeah, it's like a hand transplant, except it's more like a penis transplant. Mm, that's crazy. Phantom penises. The signal to noise ratio. Think of gender dysphoria like a high-pitched feedback loop in a sound system. The somatosensory cortex is sending a signal. Where is part X? The body responds. Part X is not there. There's no penis? The limbic system responds with panic, distress. Where's my penis? Where's my penis? Right. So it's not there, so you panic. Surgery and hormones don't have to be perfect to be effective. By changing the body's shape and the brain's chemistry, you dampen that feedback loop. The noise of the mismatch drops from a 10 to a 2. In clinical terms, this results in a massive drop in depression and suicidality. Yeah, okay. Like a transplanted penis is better than no penis. It's what they're saying. It's basically what they're saying. Which makes sense, right? I get it, right? Yes. Yes, right. 4, why can't we fix the brain instead? Why don't you just rewire the brain? No, it's too complicated. A common question is, if the brain is the part that's wrong, why not change the brain to match the body? Yeah, no, it's too complex. We don't have the ability to rewire individual neurons with precision. The foundation problem, as we discussed with sexual orientation, these maps are laid down in the basement and core foundation during the first and second trimesters of pregnancy. Yeah, it's just deeply ingrained. So when you are still a fetus, the first and second trimesters, right? That's the first, and so that's very early on. It's already done. The shape of it is already in place. Total system failure. You cannot rewire a person's core identity or body map without essentially destroying the cerebral cortex entirely. Like you have to like pull all the wires out, and that you kill them if you do that. It would be like trying to change the foundation of a house while it's still standing. The whole thing would collapse. Well, I mean, look, you can kind of do that if you do it really carefully with a house. There are videos of people doing this. You can like, it is actually possible to change the foundation of a. It's a lot of work though. The brain, we can't do that with the brain because the brain is more complicated than a house. But yeah, it would be very difficult, and you would like have to pull all the wires out, and then they die. The practical part, it is surgically and chemically easier to change the siding and plumbing, the body, than to rebuild the foundation, the brain. Yes. So because we can't change the brain, we have to change the body. By the way, if you could change the brain, you could change anything about anyone. You could change their identity, you can change what foods they like, you can change, like, you can give them phobias, you can take away phobias. Like, if you can do that kind of detailed rearrangement of neurons in a person's brain, you can change anything. So, that would be an interesting dilemma, interesting ethical dilemma. Like, imagine if somebody was scared of spiders, right? And you say, well, I can change your brain to make you not scared of spiders. But that's a part of your identity, right? You're changing who they are. Or like, somebody really likes sushi. And you can, well, I can change your brain to make you not like sushi. Like, what the hell? You can change my brain to make me not like if you change every part of a person's identity and they become a different person, what the hell does that mean? So we can't do that yet, but possibly at some point in the future, technology will advance enough that you can change anything about anyone. Change their memories, change who they are, change what they like, change what they don't like. Crazy. Okay, so that's it, I think. Very interesting. So we talked about sexual orientation and gender identity. Extremely interesting. Extremely interesting. I'm just gonna like double check this just to make sure. I think this is correct. Phantom penises and penis transplants. Yeah, no, there's only green, there's no reds. Okay, let me end this one here. Next one, I think we'll just do a little conclusion. We'll step back from the neuroscience and just talk maybe more generally about the implications of what we've been talking about, like what the brain is, how it works, and what it means. I'm not sure where that's going to go, but I'll see you next time, see what happens.